So today I want to implement. I actually don't have a specific idea for now, but I'm planning to 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 mine some ideas from LLM. Yeah, and basically it's the main idea uh, to obtain some kind of maybe new algorithm which I didn't implement yet, and implement this using LLM and guidelines from LLM and whatnot. Uh, and I want to do this because I see that a lot of people, they actually don't know how to use LLM appropriately. They're trying to solve their problems with I don't know, with end-to-end approach, like write for me this kind of function. They just copy paste this function and call it a day. But it's not a robust way to do stuff with LLM. And I want to explore this opportunity to take some novel idea. I mean, novel for me personally, and just implement it using LLM. And I want to do this as usually using raylib, but now I want to use Python. Recently, a new version of Python has been released, and I want, actually I already installed the new Python. For some reason I have Python 3.14, but the new release is 3.313, I suppose. But I just cloned the repository and built the newest branch. So yeah, and this is the new Python, and yeah, I want to use raylib and this new Python. And as you know, there are some bindings which exist for raylib in Python, but I don't want to use them. I just hate bindings because honestly I don't even understand why people use bindings, especially in raylib. Raylib has, I don't know, 100 bindings, and or maybe less, maybe more, I don't know. But honestly, I don't understand this stuff because it's not a huge deal to create a binding. It's a huge deal to support this building and keep it up to date with new versions of raylib. And I recently checked the bindings for raylib in Python, and they provide bindings only for raylib maybe 4 or maybe 5, but the newest raylib is already 5.5. So basically it's much simpler to write bindings by yourself. But also I never wrote any bindings in Python for C libraries, so I also will be using LLM for this kind of problem. Yeah, so let me mine craft, what is the correct word, let me pick random ideas using LLM, and I use this plugin for Vim, Code Companion. I attached my not ChatGPT, Anthropic key to this stuff, and I can use it simply in my Vim without browsing, without this shitty UI and so on. Yeah. So let me first craft few ideas. Let's say I want to explore new ideas to implement in raylib and Python. Not recently, I've already implemented various stuff. I just want to enumerate some things that I already implemented, just not to repeat, for LLM not to repeat these ideas. Like voids, like Berlin noise terrain generation, like simple 2D physics, and some more. Don't use these ideas that I've already implemented. And yeah, and by the way, there is a great chance that my English is not particularly correct grammatically, but it's okay. For LLM, it's okay. It will understand this. Don't use these ideas I've already implemented. Provide me a list of 100 new stuff, including algorithms, interactive graphics, ideas, maybe not ideas, applications. What else do we want? And so on. Let me cheat. And so on. Yeah. And now I can ask for completion. Game mechanics, interactive file, data visual. Okay, maybe it's enough. I don't want to read this stuff. I just grab it. Close the sheet. How can I remove /d plus, not plus, /d. I don't know how to write a regular expression for this, so I will just pathetic. Okay, so I have this list of ideas. Let me now save this ideas txt, and let me pick the random one. And I will do this only once. So it's fair experiment. I will do this only once. No, yeah, once is enough because it's random. So let me open the file. Ideas txt. File is equal ideas txt, and after that I will what? File read lines, line strip for line in read lines if line is if length of line is greater than 2. Okay, and this is my ideas. And let me just obtain set just in case. Ideas is equal. Okay, and now I want to select the random one. I will just shuffle this list. How can I do this? Import random shuffle ideas. This will shuffle ideas in place. Yes, this will shuffle ideas in place, and after that I just print the first one. So and I will perform this only once. Let's go. Fuck. Well, it's a little bit annoying, to be honest, because it's not a particular algorithm is just an idea, but I want it to be more dense technically and mathematically. Let me think. Can we expand this idea by using some specific maybe mathematical algorithm? Because I can do this easily, but I want a challenge, so I need some kind of unexplored algorithm. Let me open code companion chat. I have this idea. Whoa. I have this idea. And I want to implement it using more or less complex but not very much complex, not PhD level stuff. Complex math algorithm or any approach. Can you provide me maybe 10 different ways I can implement this generator? Let's check. Voronoi, else, yeah, it's nice, but I already did Perlin. Automata, fractal, it's new to me. Graph theory is new to me. Wave function, I never did wave function. Poisson disk, I did Poisson disk, but not very often. Agent base is a good one. Constraint, yeah, I think these ideas are nice. Can you remove Voronoi, not Voronoi, Perlin and Automata? Yeah, Perlin and Automata, since I already did them. Introduce two new ideas instead of these ones. Let's go. Hierarchy, I have no idea. Yeah, I never did hierarchical space partitioning. Attraction, I have no idea. Yes, it's fine. Now just provide me a simple list. One idea in a line without numbers. Okay. So first of all, we have this. I just don't want to forget this. Where can I write this? I have new list of ideas, and I just reopen it. Ideas, okay, and shuffle and pick the first one. Okay, wave function collapse. All right. For building types. Okay. Also. This is our idea, this is our method. And maybe Yeah, maybe it's enough. Maybe it's enough. Maybe it's enough. Okay, I close Python for now. Exit. By the way, they fixed exit function, not function, it's now keyword. In the earlier Python, you need, this is Python 3.11, and if you write exit, it's just complaining that you need exit function, exit. And it's so annoying, it's so annoying. And now in the new Python, you can just exit. And it's brilliant. They should have been done this much earlier, though. Okay. So let me create a directory. Make directory town generator. Town generator. Let me download the raylib. Yeah, I just grabbed the latest zip archive from the repository, and this is my idea. Let me open town generator. I will create the readme file, readme.md. I just put it here for now. Yeah, and now let me create town generator. Let me create a new Python environment for this. Python 3. How can -m venv. All right. And now if I activate this, yeah, now I have Python 3 14. Python 3. And by the way, do I have pip? Yes, and we also have pip. Now and let me unzip raylib and just build it. Raylib src and how can I build raylib for in order to compile it as a shared library? Make file lib, yeah, raylib lib type. I need raylib. Make shared static shared. Make raylib lib type shared. Let's build raylib. Yeah, and as I can say, I never implemented, maybe once or maybe 2 times, I don't remember, but in general I don't know, I don't have practice to implement bindings for C libraries in Python, and I will use LLM for this to help me, to guide me, or maybe just to copy paste the actual code. Let's see, we'll see. Let me copy raylib src lib raylib. It's not, no, it's not shared. Why? I didn't build it correctly for some reason. Raylib master src. Yeah, something is wrong. Maybe maybe no. Static or shared. Maybe I used make arguments in the wrong way. Let me just hard code it here. Shared. Okay, and let me rebuild. Yeah, now I do have this shared library. Move this stuff in the main directory here and just delete all other stuff. We don't need any more master, we don't need raylib master anymore. All right. Now let's start main.py. So I have raylib.so.5.5.0 in the current directory. Can you write a simple hello world? Draw a circle in the middle of the screen using this solib. Write simple binding and apply them. Let's go. Blah blah blah. C types, load library, structures. Yeah, it's classical stuff for implementing bindings. So let me just grab this. Okay. I will close this for now. Let me explore this code. Let me explore this stuff. First of all, I will run this. Do we have any backdoors in here? It's okay, even if you do. Let me build this. src tutorials, town generator, activate Python environment, and let's just run this Python main. I don't see a circle. Let me draw a circle. I want a circle. Be clear background, white. We take the center of a screen, screen width, screen height, yeah. And we just draw a circle with radius 50 pixels. The whole screen shouldn't be red. Let me set 5 pixels. Something is wrong. But why? Let me comment this. Okay, no. It's red. Why is it red? Town generator. I have no idea. I have no fucking idea. Okay. How can we explore this? Clear background and drawing. Okay, let me clear it with blank. Do I have blank? Okay, now it's working. Let me try. Maybe it expects, but why? Maybe. For some reason, go to definition doesn't work in this. I suppose that language server is not ready for the new Python, unfortunately. Yeah, well, let's use Python 3.11. Sorry for this. deactivate rm minus ref env Python. Yeah, I just don't want to hustle with language server for now. I just want to implement interesting stuff. Maybe I will handle this problem later. And I kind of prefer to use language server to navigate my code faster, to explore documentation faster, and so on. Let me quickly create Python env. Which Python? No. Yeah, I need to activate this stuff. Activate which Python? Python. Yeah, 3.11. And let me run main. And now if I open the main code, I hope I can navigate now. No, I cannot. Yeah. This is because a language server needs a package. Let me quickly create the package. For some reason, I don't know why, and I don't want to. Let me remove env. Deactivate. And now I create. I think with new Python this also will be working. Okay. Python 3 minus n env. Activate. Sorry, a little bit of brain farting. It's okay. Activate, make directory town generator, move main town generator. How can I create simplest install? Let me create setup.py. I have no idea how to create these fucking setup files. Write the simplest possible in the world setup.py. Blah blah blah. Yeah. I love this. Name town generator version. Let's okay. Cannot be resolved. Okay. And now let me install this. Pip install -o -e. So I installed this package in the development mode. It means that if I change something in my actual code, it will be automatically included in the Python, because Python is watching this current directory for the specific package. Let me create init.py and let me try. No. Yeah, new Python import town generator. Yes, town generator version. I don't have. By the way, check this nice looking trace logs. I don't know why do you need this strange purple color, but it looks much better than in previous Python versions. Anyway, okay, where did I stop? Here, yeah. Let me now try to run this Python town generator main. Okay, and now I hope. Now let me try to navigate the code using go to definition. Yeah, now it's working. Now it's working. I can check structure. I can check this one. Nice. Now let me handle this problem with circle. When I'm clearing the color, first of all, when I'm clear, let me create, for example, red color. Let me create red color, background color, like so. Like so. So now I want to see the red color. Okay. RG. Now let's check green color. No, it's not correct. It's not correct. Color is what? Color is what? C int. But in raylib, as if I remember correctly, in raylib color, it contains it consists not of integer values but unsigned character values. So it's char values. Do we have the C yeah, u int 8. I need u int 8. So as you can see, ChatGPT is not always, I would say it's always not correct. It's always not correct, 100%. But you need to tweak the, and that's why you need to tweak the responses. Vector 2, yes, agree. Let me, whoa, yeah, now it's green. But is it green? Is it green? It's a little bit bright for green, but maybe it's green. RGB, now it should be blue. Yeah, probably it's correct. Now let me create background color 255. Yes. And screen width, screen height, let's say nice. Raylib Python, let me name it. What are we doing? Town generator. Town generator. Define colors. Main gain loop. Begin drawing. Clear. Now let's draw a circle. Center. Screen width, screen height, blah blah blah. 50 pixels. Red color is equal to color 255 0 0 0 255. Red color. One, two, three. Yeah. Nice. So basic hello world. Do I need to move bindings somewhere else? Nah, maybe I don't. Let's start just in a single file. Raylib, it's obvious. Define necessary structures. Let me call this bindings, raylib bindings. And as I can say, you don't need third-party bindings. That just throw away this garbage, this fucking stupid garbage. Just with all respect to the people who did these bindings, I don't blame them. I just blaming the general idea of depending on some kind of external bindings. You literally can implement bindings by yourself with few lines of code. Maybe at least in raylib, because raylib is very simple. Especially when you have LLM and you know what you are doing. You just need to fix some kind of mistakes and that's it. And if you want, you can factor out this in separate file, name it like bindings and support it by yourself. It's totally fine. Bindings, let's call this globals. Let's call this main. That's it. Clean up, center. All right. Now what? Now we want to start to implement our main idea. And our main idea was this. Let's start. I want to implement this one. Using this. Let's start without the code. Let's start with let's begin without any code. Provide me very concise and specific plan. If you want to use some specific math algorithm, just provide the name. Don't explain how it works. Details later. Let's go. And while we chatting with this machine, with this AI, I will smoke. If you are not against this. Concise, specific plan, blah blah blah. Define building types, constraints. So first of all, what are the constraints for building types? Grid. I understand what the grid is. Implement wave function collapse. Details later. Generate street network using L system. It's nice that we can incorporate more complex mathematical stuff, not only the wave function collapse, but as you can see, we will use L systems. Maybe. I have no idea what this stuff is. Place buildings. So if I understand correctly, we place buildings using the wave function collapse. So wave function collapse is basically for layouting buildings, and this concrete just for street network. I don't know. Let's continue. Generate buildings detail, size, elevation, and so on. Water. Yeah, it's interesting project. It's not so simple. Maybe it will take me maybe several sessions to implement this stuff. I like this. I like this plan. I like this plan. Let me even let me even put it in my README. Town generator main idea. Main idea. The plan, like so. Are you talking about just height, width, rotation, and so on? Yeah. No, I was wrong. It just yeah. It's about wave function collapse for town generator. We are talking about more than just physical dimensions. Here's a brief overview. Yeah. Footprint sizes. Maybe we don't need all of these restrictions, constraints, but we will use some. Zoning, size variations, orientation. Also, yeah, and also these ones also include geometrical restrictions. Let me save this. Let me take my code. I have this basic code. Ignore raylib bindings. Not ignore, but let's just say let's begin with let's start with these constraints. Implement basic self-contained functions for the restrictions initial definitions. Don't write any raylib or graphics code for now. Use snake case. It's just by default all LLMs understand that if you're programming in Python, you usually use snake case. Let me begin. I like this. So we have an enumerator. For building types, we have adjacency rules. Basically, I'm not sure that I want to keep this in a function, but I will factor out this. Okay. So if I understand, adjacency rules are just, you know what? Don't write any explanations in a plain text. Use doc strings to communicate all these or all this. I don't know, all this stuff for me. Dictionary which building types can be adjacent to each other. All right. Restrictions. Calculate the maximum number of each building type based on the grid size. All right, grid size. Yeah, and some kind of hard-coded values. And we have only one church. But proximity. Check if a building type can be placed at a given position relative to the town center. Interesting. So if I understand correctly, basically you can introduce any sort of restrictions. They just need to be meaningful. Or actually they don't need to be meaningful. They just need to be maybe programmatically and logically meaningful, but not from the common sense perspective. All right, I like this very much. Sorry for this noise. Sorry, it's somewhere from the street. Okay, let me wave function collapse. Is it correct? Yeah, collapse. I put it here. So let me run the stuff. Adjacency rules. Let's factor out adjacency rules into just a global some global variable map. Maybe later I will factor out this even in some maybe JSON file or YAML file, or maybe not. Get density restrictions. Also factor out grid size and density restrictions. Fuck. Sorry. Okay. Let me run this. Do we have, yeah. Nice. Now provide me a brief description for the next step. Don't write any code for now and keep it concise. Town grid, initialize each cell. Okay. Let's create grid, initialize it. Define a function to update cell possibilities. Let me just check the main idea. I understand that creating a grid is not a huge deal, but I just want to obtain some positive feedback. I just want to validate my my ideas and my understanding. Initialize grid. So we basically have grid, which is list of lists to the grid, and it basically none, and it filled up with none values. Then we initializing the grid. We take set grid size. Why choose the grid with all yeah. Since this is wave function collapse, and if I understand correctly, when you initializing wave function collapse, when you initializing a grid for wave function collapse, you basically provide all possible values for each cell at the beginning, and then you begin to collapse them. Let me wave function collapse. Grid size. Let's create a grid. What is this list of do we really need optional here? Maybe yes, because can we collapse with none? Adjacency rules. House, shop, church. No, we cannot. No, we cannot. Do we need to create a separate type of the building which represents empty cell? Maybe we don't need to set the type of a cell to be optional. Maybe we just want to introduce this building type none value, enum value. You're right, of course. What else can you say? Stupid machine. also you don't need this initialization function. Just initialize the grid in the global space. So building type, grid size, blah blah blah. Building type, grid size, set from typing, import set. Let me maybe create a class for the grid. Class grid width height let's maybe call it world. Well, let's call it grid for now. I don't need this. Grid size. Let me create grid. Grid. Maybe let me create a global grid. Proximity. Here globals grid is equal to grid width. Well, let's begin with 100 for now. Width height, density restrictions. Yeah. Grid size. No, height is here. So we basically first iterate over all the rows, and inside this iteration we iterate over all the columns. It doesn't matter in this specific case, but in general I prefer to keep this convention, to stick with this convention. Width like so. This is my grid. Do I need to place density restrictions inside the grid class? I don't know. Maybe let me just comment them for now. just comment them for now. And create the grid. I already created this. Let me just print grid. I don't want to refactor this manually. Let this shit works. Why am I paying money? Can you please refactor the grid code such that all this stuff is a part of the grid class. And for these simple tasks, like when you want to refactor stuff, when you want to summarize stuff, you even don't need to check. The correctness of this. ChatGPT and LLM in general works fine for this simple stuff. But you know what? I want to. Well, I already have 6,000 tokens. I don't want to spend too much on this simple refactoring. But maybe I can start another chat. So density restrictions, calculate density restrictions. Okay. Can you please remove this method? Just write a simple code directly in the constructor. Constructor. It's okay. Okay. Building types. Much simpler. Yeah. Stupid naming. Total cells what? Total cells number, but if you want to place number, just place n here. Total cells what? It's right. Whew. Uh, Now what? Now what is the next step? How can we continue with this wave function stuff? Great, fine, blah. Let me read. Implement method to find the cell with the least entropy, fewest possible building types. Understandable. Create a method to collapse a cell. Choose a building type for it. Understandable. Develop a method to propagate constraints after collapsing a cell. Develop a method to propagate constraints after collapsing a cell. What does it mean? So if you collapse a cell, it takes one specific, one concrete building type. And after that, it influences the actually neighbors of the cell. Maybe this is called propagation of constraints. Maybe yes, maybe not. Find lowest entropy cell. Next steps. Find lowest. Develop propagation method. Implement all other three steps in one simple, concise, single function on the grid. Maybe initialize call generate. Okay, but I asked maybe initial. Okay, generate. Propagate constraints, generate, update and generate. Clown. Find lowest entropy cell. So we need this function, yeah? Okay. This method, they call it methods. Check proximity. Optional. Optional. Entropy random. Okay. Find lowest entropy cell. Sorry that I'm not commenting each step by myself. I just don't have the skill to do that right now. It's kind of difficult for me to talk and to code simultaneously in the same time, at the same time. Generate. Okay, and now I want to actually factor out. I just don't like this function. This is a single function and it used once here. Why do I need this function? Check proximity. I don't even use this. Generate. I don't need this one. Okay, this is my grid class. Can you remove all, can you remove generate function, just move the code directly into generate, and also, and what else, and find lowest entropy cell, because we don't need this function anywhere else. If we do, I will factor it out later, but for now I just don't want to create additional entities, functions, classes, and also this one. Go. Great. Generate. Why is it 1000 tokens? Maybe it's talking about output, I don't know. Can you implement nice or nice? Wrapper method for the grid class. Don't print the actual cells, just print the number of each building type. Blah, blah. What? What the fuck are you doing? I just broke the LLM. Let me begin from the beginning. Let me start from the beginning. Grid. I have this grid. I have this grid class. You need to factor out all unnecessary methods like update cell. Actually, unnecessary methods which are used only once. Just use just place where it is used. Let's go. Yeah. Also, write wrapper for the grid. Don't print all the cells, just output basic stats for the grid. So let me run. Yeah, and as you can see, collapsed cells. It's interesting. Building counts. I like this. I like this. So basically, it's let's say superpositioned grid. We need to collapse the states of each cell. And how can we do this with generate function? But maybe I don't. Do I really need the ungenerated grid? How do you think? Maybe we want to animate the process of collapsing, but for now, let's say I don't need. Let me make it private, and I will just generate it here. But I don't like generate. We already generated it. I like initialize. We want to initialize. Initialize. Like so. Okay. It's very slow. It's very slow, unfortunately. Unfortunately, it's very slow. Let me optimize this stuff. It shouldn't be too much slow. It shouldn't be too much slow. I understand this is Python and so on and so forth, but it shouldn't be too much slow. Let me find the bottleneck of the performance. Initialize. So initialization contains bottleneck, or even it contains a bug because it's while true, and every time you see while true, it's probably a bug inside, and you will iterate this while loop forever. If not candidates, let me print len candidates. Yeah, it's just basically looping forever. This stupid stuff looping forever. Now find a bug in the current doesn't guarantee that entropy of cell will always decrease. In some cases, a constrained propagation might not change the possible building types. Are you sure? Situation. Ensure keep track. Before I apply your changes, can you please suggest me some places to introduce debug print statements to validate the bug reason? After finding candidates. Yeah. Good one. Basically, it's just too much time needed to collapse all cells, maybe. Candidates. Yeah, maybe it's working. Collapsed cells. Okay, this is the final lines of this debugging. Is almost fully collapsed. Incomplete collapse. The grid cells remains uncollapsed. This might be acceptable depending on your requirements, but ideally all cells should be collapsed. Building distribution doesn't match the density restrictions. For example, there are more taverns than expected. Really? Yes, maybe much more. Yeah. Maybe I forgot to. I have this. Maybe I forgot to include none cell in the density restrictions when I was copying pasting code from the LLM. I have these building types. Can you maybe fix the restrictions? No, I also have none. Yeah. Yeah, and I understand that it's not particularly good code, but for now it's alright. How is this? I already have this, yes? Yeah, none. Yeah. No, still incorrect. this is still incorrect. Fix the whole class. And after fixing, show me specific places where you did it and explain why. Yeah. Also, I don't have non-adjacency rule. Yeah, maybe if, well, I should say, if you understand how to code the wave function collapse, you should do this by yourself. But I don't understand this. So I just want to cheat a little bit today. I just in a mood of cheating. But it's okay. I own nothing to nobody. That's why I can do this. Just paste it here. Adjacency, yeah. Now we can transform from house to non-cell. Not transform, but we can be adjacent with house and non-cell, with shop and none, and basically every cell type can be adjacent to the non-cell type, building type. And non-type can be adjacent to every other type. Okay, what else? Adjacency, agree. Initialize building counts, choosing building type. Yeah. You update cell. Move to debug print statements here. Incomplete collapse. Yes, these two we just discussed. Distribution, yeah, they basically stopping to generate specific building types when the desired distribution is achieved. Infinite loop by allowing class fallback, we avoid getting stuck. Okay. I want some kind of indication. Initialize. Yeah, now it looks perfect. We have 6,000 houses, 2,000 shops, blacksmith, tavern. Basically, maybe. Wait a second. It's too much, don't you think? It's too much. It's too much. I want I want the none cells to be, what is the word? I want to have much more non-building types. Now in the current params produce too dense city. What do you want? Density restrictions. Initialize total buildings. Okay. But what about none? Do we need and increase none? Yeah. Agree. Like so. And maybe I want to make the grid smaller. Maybe let's say 30. Nice. Very nice. Very nice. So now we can just draw this stuff, yeah? We have grid. Let me briefly check the implementation. I just want to understand what do they do here. While true. Okay, we iterating until we collapsed all of the cells. We have entropy, and entropy, if I understand correctly, it's basically some measurement of uncertainty of the cell. So if you have, for instance, only one possible building in the cell, it means that we have zero entropy, I suppose, because we have zero uncertainty. Candidates, and we now iterating over all the cells. Interesting. What's the complexity of this algorithm? So here is already n square, yeah? Iterate over all the cells, n square. Well, not n square, but width times height, but we just simplify it and say that n square, where n is the grid size, the grid side size, n squared, yeah. Grid size square. Okay, and then if current cell is not collapsed, basically the number of possible candidates in the cell is greater than 1, we compute entropy, and entropy is just the number of possible outcomes. Let me a little bit factor out this stuff. Cell is equal cells y x I don't like y and x for rows and columns. I just like to explicitly say row call. Cell is row call, row call, row call, row call. We have cell entropy we can generalize this stuff, it's not a big deal. We can say that entropy is equal to len cell. And now if entropy if entropy is greater than 1, and less than mean entropy, greater than 1 and entropy is less than mean entropy, I say this, else entropy greater than 1 and this one I say this. What is the mean entropy? Mean entropy, yeah, we update mean entropy on each iteration. So I iterate over this grid, I take each cell, I check the entropy, and if the cell is not collapsed, I basically perform these operations. Can I just say that if is collapsed, I just continue? I just continue and I don't need this. Okay. Also, we can update mean entropy, we can update it here, because in this case we just assign the same value, it's not a big deal. Maybe it will slow down the algorithm. Since we are working in Python, it definitely slowed down, but not much, not too much, because we have a lot of heavy operations and hard operations inside this algorithm. So I think the simplification of visual representation of the code it's also important. Mean entropy is entropy, and now if entropy is less than minimum entropy, so basically we obtain new best entropy. Yeah, and we just update all our candidates. We just saying that okay, now we have new set of candidates beginning with this new specific cell, row and column. But if entropy is the same, if I cannot do this, I cannot do this, because of course it will be equal to mean entropy. How can I handle this concisely? If entropy, yeah, I just need to put it here. if entropy less than mean entropy. Okay. So we are collecting some candidates, but what are the candidates? All cells. Yeah, these candidates basically candidates for collapsing. And after that, collect candidates for collapsing. If not candidates, next, collapse collected candidates. We pick the random one, the random cell, X and Y. But it's okay. And now we want to, what do we want? Possible buildings. We take the building, we iterate over all the buildings inside the cell, all possible buildings, because the cell is not collapsed, and it means that it has more than one possible building. We iterate over all these buildings, and we collect possible buildings if the total number of this type of buildings in the whole grid is not larger than the allowed maximum. And our maximums are in these density restrictions. But it's not density, it's number. Density is not measured in the absolute values. It's funny naming from LLM. If not possible buildings, yeah, we just collapse it into non-building type. Yeah, and if we cannot satisfy the restrictions, we just collapse it to be none. Building type. Otherwise, we just pick building type. Let me refactor this stuff like so. Building type is equal to building type none if not possible buildings, else, well, maybe it's okay. Fuck, what am I doing? Building counts iter. What are you doing here? Well, iterate. Yeah. because each cell is a set of building types, and if I collapsed some cell, I have single building type, but I need to keep it as a set type, as a set data structure. So how can I create set? I already, yeah, like so. Building counts. Now I just want to take this building type and count it like so. I honestly don't understand why the LLM cannot write the concise code. Why do you need this motherfucker noise? What is this? Propagate constraints. This is interesting. I don't understand, but maybe I do. So we basically, this is classical up, right, bottom, left directions. We take the difference in x and y. So we want to step right, step up, step left, step bottom. We obtain this new x and y. So and if I understand correctly, it's just new, not number, not. We check the boundaries. We need to be inside the boundaries when we, if for example, if you're stepping left in the first cell, we basically overshoot the actual grid. So we need to check this condition, and after that we update cell. Let me check how can we, how do we update cell? Update cell, possible types. Okay, we iterating one more time on these directions. We get new, check boundaries. Yes, I understand. So basically what's happening? Let me draw this. What is this? This is from previous. Let's say that I have a grid. Maybe let's say that I want to propagate constraints from the collapsed cell, yeah, and as you can see, it's definitely collapsed because it has only single building type. How long am I recording? Oh, 2 hours. Maybe I need to smoke a cigarette. Yeah, let me smoke a cigarette. I don't want to stop the recording. And if you want, you can smoke a cigarette with me. We want to propagate constraints from the collapsed cell to neighbors. And here we updating cell. Okay, let's say that I have some kind of collapsed, let me mark it green, cell here. And now I want to propagate constraints from this cell here, here, here. And if I understand correctly, propagate constraints basically means that I want to resolve all contradictions, because now when I collapse the cell, I have only single possible building here, but this cell, and this one, and this one, and this one, they may contain buildings which cannot be adjacent to this green one, and we need to update this information. And for each neighbor, we updating cell. Let's say we updating this neighbor. I iterate over all neighbors for this specific neighbor. Let's say blue. I take this one, this one, this one, and this one, yeah? Not take, check, I'm checking. This 4. And for each of these 4, I take the first and single, maybe not, yeah, no. What are you doing here? Yeah, I said it a little bit incorrect. If this neighbor cell is also collapsed, if it's also collapsed, so basically if I also have only single possible building type here, I take this type and I say that possible adjacent neighbors for this blue cell defined by our rules. So I basically I'm saying that possible adjacent building types for this blue, for example, another blue, maybe another green, maybe red, these my possible types. And I collect them in some list or set. Set of possible types. And after that, I'm checking if I have some kind of possible types. No, it's not correct. This X and Y, it's already the blue neighbor. Let me do it one more time. It's already new neighbor. I'm taking all other neighbors, and for all other neighbors, I'm checking that the neighbor is collapsed if the neighbor is collapsed. So, for instance, let's say that this neighbor is collapsed. It's just a red building. If this neighbor is collapsed, I'm taking this building type and put it in the possible types. And possible types are defined for the blue cell. Yeah, so basically it was correct. It was correct. I have a set of possible types. I have red here. I definitely have green here, because I have a collapsed neighbor from the right side, which is green. I have green, and so on and so forth. For example, this one is also collapsed, and this is orange, brown, I don't know what the colors. And let's say this is not collapsed. It may be blue, brown, and red. And I have these possible types. If I have some possible types, I just perform logical AND. Basically, logical AND in case of two sets, basically intersection of these sets. Yeah. So I'm saying that type of this cell is the intersection with these colors, with these possible colors. And I don't have blue color here because this cell, no, I have, in fact, I have blue color here. No, I don't have blue color here. I don't have blue color here because these colors are possible adjacent cells for my neighbors, and my neighbors don't have possible blue neighbor color. So yeah, I don't have. And when I perform the logical AND operation with this set and with my actual building types, I basically eliminate all possibilities, and my cell becomes none. But if some neighbor allows to have blue cell as a neighbor, I will have this blue candidate, blue possible neighbor here, and when I'm collapsing, I just leave this blue building type. Oh, a little bit convoluted, but I'm just trying to understand all this procedure. But I think I understood this. We update this, and that's basically it. It's a simple stuff. It's very simple stuff. But I don't like the complexity of this stuff. I don't like the complexity. But maybe can we do something else? Can we do something more optimal here? Iterate. I will think about this. I will think about optimizations later, because for now, let me close this. For now, we already have more or less good speed for initialization of the grid. All right. So basic stuff, basic generation stuff is finished. Now let me draw cells. Let me draw cells, and then I will make a break. Okay, let me implement grid draw function for the grid. Def draw. Grid draw. Let me define camera. you need to wrap grid draw in the main loop into begin mode 2D camera and end mode 2D and mode 2D. Create bindings for this. Why do you need this pointer? Raylib bindings. Camera. Begin drawing. Okay, now I want to create camera in globals. Camera is equal to screen width, screen height. Rotation, zoom. Let's say zoom is equal. Let's just keep 1 for now. Now you need to implement grid draw. Draw rectangle, agree, building colors, agree, draw circle, draw rectangle, like so. Okay, draw. I will examine it later, as always. For now, I just want to obtain some working solution. What the fuck are you doing? Draw and why do you need end here? Hide, start. It's lines. Do I need lines? I don't need lines. I just want to draw all the rectangles, yes? If length cell. All my cells should have length 1 after collapsing. must have. So I just assert this value. Building type, color. Let me move building colors in grid. Here. And also, I like, it's a static variable. It's a static variable. It's not a self variable. It's more like static variable. So I use a class name here. Cell width. Screen, let me call the screen size. Let's assume that all my application is just the rectangular stuff. Just the rectangular stuff. Screen size is, maybe it's not very flexible, very what is the word, very generic approach, but in my case it's okay. In my case it's okay. Let's try. Cool. Yeah, but here is a problem. You can clearly see that we are starting to propagate, to fill up these cells from the bottom. How can we solve this issue? How can we solve this issue? I have this wave function collapse but when the grid is generated, I clearly see that cells started to fill up from the bottom of the grid. Basically, when the number of some specific building type reaches the upper bound restriction, we stop to generate this type. Can we somehow fill up the grid not from the bottom but in a random manner, like Monte Carlo? Shuffle. Yeah, basically the same, but we shuffle X and Y, we shuffle all the cells, I suppose. Initialize. Yeah, old self, we shuffle, and then we just the same stuff, the same stuff. What? Did I ask for this? Did I ask for this? No, I did not. Propagate constraints. Okay. Nice. Nice. I see the church. Maybe I should make the church a little bit brighter. Church, light yellow. As you can see. Okay. What else can we do? Maybe I should draw sprites, but maybe we can leave it as it is. What is green, by the way? It's a house. I don't like these colors. I don't like them. Let me create for houses. I want to maybe I want to have maybe brown color, and brown is the combination of what? Red color, green, a little bit of green color, and no blue color. And by the way, it's a lot of houses here. I don't like so many houses. It looks strange. But maybe it looks fine. Yeah, maybe it's some kind of a town. Maybe it looks fine. But I don't like the color. I don't like the color. I don't like the color. Maybe like so. Yeah. Maybe the color of poop is fine. A little bit dark. I want a little bit like maybe like so. Yes. Nice. Shop. Shop is do I really want to deal with let me just get rid of blue color. I just it looks like water. I want maybe shop. Let me make it dark green, like 150, and a little bit bluish. No. Yeah, maybe, but it looks like a forest. It looks like a forest, but anyway. Church, tavern, blacksmith. Yeah, it's okay. It's okay. Let me dramatically decrease the number of buildings. Houses, like so. Shop, like so. Yeah. Tavern. Blacksmith, maybe like so. And 2 churches. No, it's not enough. Let me put the absolute values here. Houses, let's say 50 houses. Shops, let's say 5 shops. Church, 1 church. Tavern, let's say 3. And blacksmith, let's say 2. Yeah. Yeah. Maybe this specific setup is not so. It's not looking so pretty for such small amount of buildings, but maybe later I can introduce, for example, like grass or trees, and trees can be adjacent to the houses, like little parks and so on. But for now, let's keep it like this. Okay. So let me make not small break. I already recording this for 2.5 hours. Yeah. What else? Yeah. And then I'll continue with another ideas, like what else do I have? Building constraints, grid, wave function collapse, yeah. And then I'll continue with this, but I don't understand what does this mean. But we'll handle it. Okay.